we have a rules theorem. Rules theorem. The question is state and prove the rules theorem. Statement. Let f be a function continuous on the intervals ab, differentiable on the ab, and f of a and f of b also equal. Then at least one point from these intervals such that the derivative of this point is equal to 0. Now we start the proof this theorem. As f of x is continuous on intervals ab. Continuous means a function is said to be continuous at x is equal to a if the limit of x up to a f of x is equal to f of a. This function is called the continuous function. A function is continuous then is bounded and f of x can attain its bounds. It means capital N and small m. Also we discussed in previous lecture, it's called the supremum and infimum of the function on this intervals. If either m is equal to supremum and infimum are equal, or supremum and infimum not equal. Case 1. If supremum and infimum are equal, then f of x is constant function. The derivative of constant, we know that, is equal to 0. It means its derivative vanish, so the theorem is true because derivative of a function at the point c is equal to 0. So our theorem is proved. In other case, if supremum and infimum are not equal, then at least one of them in difference from f of a and f of b. If a function is constant, then f of a and f of b are equal, then the function is vanished. As we say that if supremum and infimum are not equal, then at least one point on these intervals where f of a and f of b are different. Now we suppose that the supremum of function f not equal to f of a but equal to f of b. F attained its supremum on the intervals of ab. There is a point c from this interval such that f of c is equal to supremum. So c is a different from a and b, implies that c belongs to this interval. By the definition of the derivative, limit h up to 0, f of c plus h minus f of c dividing by h, we know that f of c plus h minus f of c less than or equal to 0. If we take the left hand limit, then the result of this function is greater than or equal to 0. If we take the right hand limit, then the result of this function less than or equal to 0. It means, but it is given that f was differentiable on this function. As we know that the function is differentiable, so then only this way the limit of the limit h up to 0, f of c plus h minus f of c dividing by h is equal to 0, because these two functions is less than equal to 0 and greater than equal to 0 and less than equal to 0. This is possible if this result is equal to 0. This is a definition of the derivative of a function. So the derivative of this point is equal to 0. The theorem is proved.